Hello friends, today we are going to a different topic in light. And last time we have done about all about reflection, a 15-minute video. Reflection, what is reflection? Then multiple reflections, then images formed by plane mirrors, and the multiple reflection formula, how to make a kaleidoscope, and how a periscope works. Today's video would be all about refraction. Just like reflection, refraction is another dimension of light. Light has three dimensions: reflection, refraction, and dispersion. Today we are going to work all about on refraction. So let's get started. Refraction. So do you get from this uh, name? Okay, I'll not ask you that question. Now take an activity. Keep a lemon in a glass of water. You will observe that the lemon appears bigger than its usual size. If a pencil is kept in water, it appears to be displaced at the interface of air and water. All this happens because light is not traveling in the same media. So whatever I told now, did you get something out of it? Here we have an image. Here we have an image. Here you can see that orange dot. Here we can see that the pencil which is dipped inside the water, it is appearing bigger, and the pencil which is outside the water is thinner, and we can see a break of the pencil where the air ends and the water surface starts. So this is all because of light. The pencil is not bending or the pencil is not increasing. It's all because of light. So how can we define refraction? Can we define it as this definition? So bending of light from rarer medium to a denser medium is refraction. So here light is bending, so we can see a break. Here we can see a break in our pencil because bending of light is happening here. So what's a rarer medium and a denser medium? Here you can see that here it's air, and here the water surface starts. So here it is water. Now, as you see, the air molecules are, it is a gas, so its molecules are dispersed, but water is a liquid, so its molecules are less loosely packed. So air is a rarer medium and water is a denser medium. So when light travels from a rarer medium to a denser medium, the light bends, and this bending of light is known as refraction. Now let's go ahead. Let's take this refraction ahead. Another definition of refraction is when light is traveling from one medium to another, the direction of propagation of light changes in the second medium. This phenomenon is called refraction of light. Now, for refraction of light, as I told, an important consideration for refraction to happen is that both the media through which light is traveling should have different densities. And here as we know, air has different density, it is rarer medium, and water has different density as it is a denser medium. Now, refraction, how the light actually bends, how the light is able to bend. The light actually doesn't bend. The speed of light in air is 3 into 10 raised to 8 meter per second. However, the speed of light in glass and water is much lower. So when the light is traveling from a medium of higher optical density or higher density, to be approximate, to a so when light is traveling from a medium of higher optical density to a medium of lower optical density, it bends away from the normal. When the light is traveling from medium of lower density to medium of higher density, it bends towards the normal. And now this normal, and when it bends towards and away from the normal, we are going to do all this now. But first of all, let's see. This is a beaker and this is a pencil. It is bent. So how this pencil is bent? Here is an incident ray, and that incident ray is bending in the water. This is known as a refracted ray. First is incident ray, and then we have refracted ray. Now let's take this concept a higher level. Now we have here air and water. Now this is air and this is water. Now we have here a normal. That normal is always a 90-degree angle, and the surface is the water surface. So the normal is a 90-degree angle to the water. Now this is an incident ray, and from the water we get a partial reflection. So we just doesn't we don't pay attention to that reflection now, because it will divert your attention from the refraction, and that comes everything in reflection, because that we'll talk about it later. Now this is the incident ray which falls over the water. Some light, it is a partial reflection, not full reflection. So the sum of the light, it comes inside the water, it bends, the light bends, and this bending of light is known as refraction. So here we can see, here is the point where the light, here the arrow has bent a little bit, and this arrow which is inside the water body is known as the refracted ray. Now, if take example which I told you, that when the light is traveling from medium of lower density to a medium of higher density, it bends towards the normal. Now here, you tell me, which is lower density? Correct. Air is the lower density and water is the higher density. So here, light will bend towards the normal. Now here we will get to know by this is the angle. Now what is this angle? This is the angle of incidence. This is the angle and this is the angle of refraction. Now as we see that the angle of incidence is bigger than the angle of refraction, so we can conclude that refracted ray is bending towards the normal. And also we can conclude that the angle of incidence is more than the angle of refraction when the light is traveling from a medium of lower density to a higher density. Now just flip the water and air. Let's see what happens. This here is air and water. Now we again have a normal here, but the source of light or the incident ray would be from the normal. Here we have the incident ray. Now this incident ray is inside the water, and this is the partial reflection which we know, and that when the incident ray, here we can see a bend. So when the incident ray is traveling from the water and when it reaches the air, it bends and it forms a refracted ray. Now here, as we know that when light bends from a medium of higher optical density to a medium of lower optical density, then we get that the light bends away from the normal. Here we can get that the refracted rays away from the normal. Just by seeing, we can check that the refracted ray is away from the normal. Here it is the angle of incidence, and that is the angle of refraction. Now here also we can check that the angle of incidence is smaller than the angle of refraction. That we can conclude that refracted ray is away from the normal. So when light travels from a higher optical density to a lower optical density, the refracted ray bends away from the normal. So we can conclude that here in this case, angle of incidence is less than angle of refraction. Now we are going to take this refraction to a higher level. Here we just saw the angle of incidence, angle of refraction, but we are going to add it a new concept, that is angle of emergence. Here is it. Now we are not taking water, because if we take water, it is not logically possible. So the first row we can see here is air, and the second row here is glass, and again the third row is air. So we can know that air is a lower density, glass is higher density than air, and this third row air is again a lower density. So what happens when light travels from the lower density to a higher density, and again from the higher density to a lower density? That we would be learning. This is the normal, and from that normal there is a ray coming. That's a source, and that's an incident ray. That incident ray, when it falls over the glass surface, it bends, and thus that bending, as we know, is refraction. Thus that ray would be known as refracted ray. Now, as we know, when the light travels from the higher optical density to a lower optical density, the light bends. Now here also the light will bend, as here the refracted ray is touching the glass surface, the glass ends, and the light needs to travel from the glass to the air. Now there is a change in the density. Here it's a trick. Here we will get an emergent ray. The light from the refracted ray is bending, and it gets to the emergent ray. Now in that between, we again get a normal. Now this emergent ray is possible, and here we can see there is no game of angles, and but still we will see the angles here. So here are the angles. This is the angle of incidence, and this is the angle of refraction, and the angle of emergence. So we can here see, just by seeing that angle of incidence is equal to the angle of emergence, but the angle of refraction is smaller than the both. Now, here also, if we see very keenly, that if we see properly and very neatly, incident ray and emergent ray, just focus on those two rays and just try to connect those. Are you able to connect? No, we aren't able to connect, because here in this case the emergent ray is parallel to the incident ray. So here it is a normal rectangular glass slab, and the air is just parallel. The lower density, which we here saw, the lower density is air, and the higher density is glass, and the lower density is air. So the lower density uh, medium is parallel to the higher density medium. So here, in this case, the emergent ray would be parallel to the incident ray. But there is an exception when the lower density is not parallel to the higher density. And this all happens in a prism. That's all we are going to learn, refraction through prism. So let's learn what is a prism. A prism is a name given to a three-dimensional solid. It has two identical bases in the form of a parallelogram. When viewed in two dimensions, it appears to be a triangle. In the normal rectangular slab which we just saw, the refracting surfaces were parallel to each other. But in a prism, there are no parallel surfaces because it's just a triangle. Let us try to see what happens when refraction occurs through prism. So we have got here our prism, and we have got a source of light, and the incident ray is falling over the prism. Now, as per refraction, the light will bend, and it happens. The light bends. But before that, here we see that the incident ray is extending. This line we would be seeing, and this line would be later in the use. But if the prism was not there, the incident ray would go straight, and that's just the extension of the incident ray. Now this incident ray bends and forms a refracted ray. And there is a normal again here. When light bends, there is a normal. Now that refracted ray is falling now at the end of the prism. Now, as we just saw in the glass slab, that the refracted ray would form an emergent ray. And if we go as per the case of the glass slab, it would be that the emergent ray would go this way. But as I told that there are no parallel surfaces in the prism, so the emergent ray won't be parallel to the incident ray. So the emergent ray would go the other way around and not on the normal side. So this is a normal. When light bends, there is a normal. So it was supposed that if the prism was not there and it was a normal glass slab, that the emergent ray should have been bended towards the normal, and thus then it would be parallel to the incident ray, but it's bending away from the normal. So there would be some angle at which it is bending. That angle is known as the angle of deviation. This is the angle of deviation. This is the sign of the angle of deviation. Here we can see that the angle of incidence and the angle of emergence is equal, whereas the angle of refraction is reduced. That's all for today. We have learned refraction. Now, just a revision. What is refraction? Refraction is bending of light from a rarer medium to a denser medium is known as refraction. So refraction, uh, there are two things to be noted, that when light is traveling from the medium of higher optical density to a medium of lower optical density, it bends away from the normal. And when the light is traveling from a medium of lower density to a medium of higher density, it bends towards the normal. That's all we have to do. And in the prism, it's just the other way around. In the prism, there are no parallel surfaces, so the emergent ray won't be parallel to the incident ray, but it would be deviated by the angle of deviation. That's all for refraction through prism. Now let's go ahead. That's all for this video. That's all for today. That's all for the part 2 of light. But that's not for you all. You have one more task to do. You have to subscribe, because when I saw the analytics of this channel, I got to know that out of 100% viewers, only 5% viewers are subscribing the video, and others are just viewing, and not even likes are there for the video. At least like it encourages me to do more videos. At least if not likes, then just subscribe. It's free, nothing. I won't earn any profits or any money from that. It's just you have to click the button. Don't on notifications. If you are troubled because of notifications, don't click the bell icon, just subscribe. That's all. Thanks for watching the video. Share this video, subscribe, and comment good in the comment box. Thanks for watching.